Other airlines here at Duxford, we welcome you to this demonstration of Concorde's nose lowering, or droop, as it's correctly called. First though, a quick bit about us. Duxford Aviation Society is a registered charity and a partner of the Imperial War Museum, looking after the 13 or so airliners collection, of which this iconic aeroplane is part. This Concorde you see before you today is a very special one. 101 is the British pre-production model. 102 as there was also a French one, each owned by their respective governments. For the first 5 years of the 70s, the pre-production aircraft carried out extensive testing, developing and refining the airliner before it finally went into service. Our Concorde here never actually carried any passengers. Our Concorde is lovingly maintained by the Duxford Aviation Society, the Aviation Restoration Team, and they are all volunteers supported by Heritage Concorde, who are a small group of former Concorde engineers. Today we'll take you on an imaginary flight from London Heathrow to New York. On the way, we'll demonstrate some of Concorde's features and achievements. A couple of interesting facts before we start. We'll be cruising some 20,000 feet above the Airbus A380s, the big Boeings, etc., and over 800 miles an hour faster. To achieve that sort of speed, Concorde needs to be very streamlined. It looks incredibly elegant, but is impractical for some stages of flight, as we will explain. The crew are on board. Today we have James in the cockpit as our pilot, and Marketa as co-pilot. Can you give us a wave? There they are, all ready to go. So, conveniently, the aircraft is ready to push back from the terminal at Heathrow and head out onto the runway. With the nose in the supersonic streamline position, the pilots have very little forward visibility, so cannot taxi safely or even take off. So the design included this nose lowering capability. Before we go, just a few more stats. We've taken on 90 tons of fuel. The crew have spent an hour on board getting ready for the flight and doing all their pre-flight checks. Passengers and baggage are now loaded and all the doors are locked and secured. Anti-collision lights are switched on. The navigation lights are also switched on. And the heat shield visor will now be lowered. This slightly improves the pilot's visibility, but they still can't see the taxiway or runway, so the nose goes down to 5 degrees. The crew will now start 2 of the Rolls-Royce Olympus engines while on the stand, and the ground connections are then released. As the aircraft pushes back, the other 2 engines are started. Concorde is dependent upon ground power as it has no APU like other airlines. So the taxi out will commence. In most conventional airliners, the pilots are situated pretty much over the nose wheel. On Concorde, the pilots are sitting 30 feet in front of the nose wheel. As you may imagine, this makes for some interesting steering as the pilots spend a lot of time over the grassed areas. We are now at the end of the runway and ready for takeoff. Engines will be set to full power no matter what the weight, and the maximum weight at takeoff is 185 tons. All 4 afterburners or reheat kick in as we go through about 70 miles an hour. We take off at 247 miles an hour. The afterburners are on for just over a minute. We are now airborne and accelerating hard. The aircrew soon begin preparing for supersonic flight, which is what this aircraft is all about. The nose will go up. You just see it returning to the streamline position. And the visor will go up as we go through the 290 miles an hour marker. We are now over land and flying at about Mach 0.95, air traffic control permitting. In just 17 minutes from leaving London Heathrow, we reach subsonic climb point just over the Bristol Channel. Again, full power and reheat, 2 thrusts, as the reheat comes in 2 engines at a time. Reheat is applied for 8 to 9 minutes until we get through the high drag to Mach 1.7, which is in our world 1,300 miles an hour. Then the reheat is turned off. The engine's and intake design enables continued acceleration to just over Mach 2. It's all very smooth at 50,000 feet, 9.5 miles up. Maximum speed is Mach 2.04, which is 1,350 miles an hour, and we are now in the cruise travelling at 23 miles every minute, which is faster than a rifle bullet. We're quite proud because our actual Concorde is the fastest ever Concorde. In testing, it achieved 1,450 miles an hour, Mach 2.23. Outside, the skin temperature gets up to 127 degrees C. 153 degrees was the most ever recorded during trials. An interesting fact once more, the Concorde would expand by 6 to 10 inches after transatlantic supersonic sector. Quite an amazing thought. I think this aeroplane actually gets longer when it's been at supersonic speeds. We're now approaching the US coast and landing. We slow down to subsonic 50 miles before the US coast and descend. Concorde has no flaps, so the pilot maintains lift at slower speeds by pitching the aircraft up at about 12 degrees. That compares to about 3 degrees for conventional airliners, exposing this huge underwing to the airflow. Once again, we lose all forward view. So, for landing, the visor goes down. The nose will then drop by 5 degrees. The nose will then continue to drop to 17.5 degrees. This angle is unique to this development aircraft. In reality, the pilots didn't like it, so the normal position was at 12.5 degrees. So at this point, just to show you now, the nose will go back to a normal angle of 12.5 degrees. As mentioned, this is a special aircraft, so for landing, the nose has to go back down to 17.5 degrees. This is unique to 101, the development aeroplane. And the landing lights are turned on. We are now in full landing configuration. We're now on final approach, nearing the end of our flight today. We are approaching at 215 miles an hour, slowing down to 182 miles an hour for touchdown. Touchdown on conventional airlines is about 130 miles an hour, so we're going considerably faster. We actually touched down some 2 hours and 56 minutes later after leaving London. Fortunately, we are aboard the first airliner with carbon fibre brakes, so we're able to stop a lot quicker than a Boeing 747, despite such high-speed landing. The nose will now go back up to 5 degrees for the taxi to the stand. So back to 5 degrees. Our pilot will shut down 2 engines as he taxis in, and we will eventually roll to a gentle stop on the stand. Once we've pulled up, we finally bring the nose back up. We then return the visor up to the parking position. and our pilot today will turn the lights off. So, we're on the ground at JFK and exiting the aircraft to find our baggage. That's the end of our demonstration today, everybody. We hope you had a pleasant flight with us today, and on behalf of the crew at DAS, we wish you a safe onward journey. Thank you very much.